Hola Ana,
Hola Manuel, ¿qué tal?
¿qué tal? ¿Cómo estás? Buenas noches.
Sí.
Bueno, bienvenidos a todos a una nueva actividad como parte del programa público de actividades de la Escuela de Arquitectura y Estudios Urbanos de la Universidad Torcuato Di Tella. Continuamos con el ciclo Archivo Redux, ciclo que ahora voy a presentar, que coordina Ana Font. Ana es profesora de la escuela y coordinadora del archivo de arquitectura, que realiza múltiples actividades de registro y edición dentro de la escuela. Y en ese contexto, el ciclo Archivo Redux, que ya está por su tercera temporada, transmite registros y ediciones que realiza el Archivo de Arquitectura de actividades que son tanto curriculares como extracurriculares de la Escuela de Arquitectura y Estudios Urbanos de los últimos años, y se reviven las ideas que circularon y fueron debatidas en la escuela en su historia reciente. Los contenidos editados son presentados nuevamente, renovando su interés cultural y potenciando su influencia disciplinar mediante su recontextualización temporal. Las transmisiones construyen progresivamente una taxonomía de la cultura contemporánea mediante la singularización y la organización retrospectiva en agrupaciones y en pares de los posicionamientos, prácticas, discursos, modalidades y diferentes sensibilidades. Hoy vamos a transmitir una conferencia del 29 de noviembre de 2017 de Kiel, Architecture and Energy in an Age of Open Systems.
Sí, gracias Manuel por la introducción. Sí, vamos a ver esta conferencia de Kiel que presenta este paradigma de los sistemas abiertos que menciona el título y cuya intención es invertir algunas concepciones de lo que implica la energía y el medio ambiente en términos materiales, políticos y formales. Y creo que una de las cosas que primero quería como introducir, que son importantes en el tono de la charla de Kiel, es este énfasis en que este entendimiento de la energía y el medio ambiente lo que hace es maximizar el proyecto, ¿no? Intensificar la agenda, el agency, ¿no? Digamos, de la producción proyectual. Eso es bastante particular, en ese énfasis, y creo que eso también habla un poco de la producción de Kiel. Kiel enseña en varias universidades, pero su producción de research funciona a través de varios libros. En ese momento había publicado un libro sobre el Empire State Building y ahora hace muy poquito publicó uno sobre el Seagram Building. Entonces eso también tiene que ver con ese énfasis en hacerlo pasar el discurso y el argumento a través del edificio como unidad también de entendimiento, que abre entonces lecturas hacia afuera, ¿no? O sea, no como el edificio como autonomía, sino justamente con todas sus redes. Eso es muy particular y quería también hacer ese vínculo que el Redux construye entre los dos semestres. El par, digamos, que dialoga con esta conferencia de Kiel de hoy es una conferencia de Sean Lally que se llama The Air from Other Planets, de 2013 anterior, y ambos formulan este par que revisa condiciones energéticas o ambientales desde distintos puntos de vista, y una cosa que los vincula es el interés por aquello que es difícil de dibujar o es más bien tendiendo a ser comportamientos más invisibles, que en el caso de Kiel es esa idea de la termodinámica como sistemas en interacción. Y otra cosa que los vincula es esta cuestión de que hay ciertos temas que la contemporaneidad trae al frente, como el problema de la sostenibilidad o del medio ambiente o de la emergencia climática, y que la arquitectura de alguna manera no ha renovado, no ha interiorizado de una nueva forma, y creo que ellos son ese tipo de agentes que tratan de generar esta mediación, ¿no? En ese sentido, en 2017 específicamente, la mediación que me parece que Kiel estaba también articulando con la termodinámica entraba en diálogo con Iñaki Ábalos, que estaba en el GSD en ese momento como director y introduciendo esta manera de mirar la arquitectura, y creo que fue un momento muy álgido y muy específico de que Kiel viniera y hablara en estos términos también de termodinámica. Creo que no insistió tanto en contar cómo funciona, digamos, técnicamente, sino que introdujo algunos temas que los quería mencionar ahora para poder un poco alimentar el imaginario a los que estén siguiendo la conferencia a continuación, que tiene que ver con que, al principio no lo menciona, pero después lo menciona explícitamente, esta lectura deleuziana de que la termodinámica es, en realidad, Deleuze dice que viene de la Baja Edad Media y que su noción moderna opone la idea de lo intensivo y lo extensivo. Kiel salta directamente sobre esta idea de lo intensivo y lo extensivo y lo desarrolla, y es importante porque lo extensivo, digamos, son las magnitudes, o sea, el volumen, el peso, la longitud, ¿no? Todo aquello que es proporcional a la cantidad de material y que es con lo que en general los arquitectos trabajan. Pero lo intensivo, que es como la temperatura, los estados, ¿no? La presión, la densidad, el color, es aquello que no es proporcional a la cantidad de material. O sea, si uno divide la temperatura, no quedan dos partes iguales, ¿no? Es un poco ese principio físico. Entonces, para Kiel eso es importante porque quiere como proponer este trabajo sobre las propiedades intensivas que están vivas dentro de los edificios como manera de ver los edificios, ¿no? Aquí está haciendo un primer reach out, que es un reach out al argumento de la generación de novedad a través del cambio de estado y a la idea de transformación de la forma. Estos discursos, digamos, están vinculados a estas postulaciones de que la relación entre energía, materia y forma es una unidad que está en constante, digamos, ida y vuelta y en sistemas de feedback interno. Después de hacer eso, trae otra cuestión, que es en realidad como una crítica velada o explícita también casi, diría ya a esta altura, a la sostenibilidad en el sentido de que cualquier mirada de ese orden no tiene propuesta formal. Entonces creo que aquí está como saliendo al cruce al hecho de que las propuestas, incluso de las certificaciones ambientales o de la idea de sostenibilidad que está muy en boga en ese momento, le está proponiendo otro paradigma en el cual eso no viene a interpelar a la arquitectura para imponerle como soluciones técnicas, sino que integra y piensa de una manera integral todo aquello que es el comportamiento como algo que forma parte de la arquitectura y por eso, como antes decía, cree y propone que esta mirada va a propulsar el proyecto y no a impostarle o a ensamblarle elementos ajenos, ¿no? Eso es interesante porque es como esta mirada de la multiplicidad y de que hay una ambición de la idea de agency. Y aquí a mí me da la sensación de que empieza a pasar una cosa, que es que hay una crítica, digamos, a la abstracción moderna, pero no hay una crítica al heroísmo determinista, digamos, ¿no? Hay una alta búsqueda de determinación, de un modo de determinación, mientras se está haciendo una crítica moderna y después se están mirando esos edificios claramente como de estado moderno, y ahí empieza a haber un primer lugar como de conflicto, diría yo, que es interesante ver qué productividad tiene, ¿no? Y creo que lo postula a propósito, no digo que sea una casualidad, pero creo que construye esa tensión y eso se instala, digamos, en su argumento de una manera muy central. Y entonces lo que le sigue es un poco qué hace con eso, ¿no? Y lo que propone finalmente es una idea de literalidad que por ahí es poco literal, o sea, poco obviamente literal, ¿no? Que es, ok, hay que calcular los pesos de los materiales y mapear cómo esos materiales llegan al edificio, o sea, hay que ver cómo el edificio aparece y se constituye en el sitio en el que aparece y se constituye, ¿no? Y a través de hacer eso desnaturaliza muchas nociones, ¿no? Como desnaturaliza, no sé, la idea de que el Seagram Building está altamente estandarizado, cuando su proceso de constitución es muy poco estándar. O sea, todas las piezas que lo constituyen, de dónde vienen, cómo se forman, cómo se fabrican, tienen muy poca estandarización. Entonces, ese es un poco el loop que hace, ¿no? Que es en sí un loop de una construcción de un argumento que toca varios lugares y creo que esto de lo literal, que son essays o artículos que han aparecido en distintas fuentes que Kiel ha escrito a lo largo de este tiempo, porque me parece que verlo hoy aquí en esta conferencia es muy interesante también en luz de algunas cosas que ha seguido haciendo, pero que son claramente en línea, ¿no? O sea, su recorrido es convergente con esta línea de pensamiento, que es que su argumento en esta postulación de la literalidad y de esta manera de considerarla, abre una especie de lugar donde deja satisfechos a muchos, ¿no? O sea, deja satisfecha un poco la necesidad de que la arquitectura no sea forzada a una especie de tecnocracia, y critica la tecnocracia, también a que no sea como evaluada en unos términos que no sean desde su propia transformación interna, y tiene toda esa parte de ese argumento. Después también tiene la condición técnica de medir, mapear, clarificar, didáctica, incluso diría, de poner sobre la mesa, de poner a ojos de todos como eso es literalmente, ¿no? Y como una especie de obviedad. Así como es como se constituye la arquitectura, y además siempre queriendo que no sea un problema externo a la disciplina, sino totalmente interno. Entonces creo que tiene una complejidad interesante en ese sentido, que casi que a medida que uno ve la conferencia está bueno sentir dónde te estás afiliando y desafiliando de su argumento, porque creo que tiene como esa capacidad de trabar las cosas para que en algún lugar, desde tu posición respecto de estos tópicos, te sientas cómodo, ¿no? Así que nada, quería un poco
Claro.
darles.
No, buenísimo. Pensaba varias cosas, quería comentarte y quizás conversemos un poquito antes de ver la conferencia. Me parecía muy interesante la relación que hacías con Iñaki Ábalos, no solamente por la temática. Sí, o sea, Iñaki tiene una investigación sobre termodinámica y tiene un libro incluso.
Uh-huh.
eh, Sí, no, pero no solo por eso, sino por algo que hablábamos en alguna conferencia que transmitimos de Iñaki Ábalos, de eh, cómo utilizaba la tradición arquitectónica o la inercia disciplinar, los temas, pero también las discusiones y los valores establecidos y las técnicas, etcétera, para pensar en el presente cómo introducir en algún punto, en algún punto que señalabas que me parecía muy interesante, internalizar una, sí, quizás una preocupación contemporánea, no sé, digo, lo de la sostenibilidad.
Uh-huh.
En vez de imponer una serie de códigos a través de una serie de mediaciones que me parece que están relacionadas con las inercias disciplinares, las incorpora. Digo, me parece que estaba ese punto también, no solo temático, sino como de estrategia o de valorización de la arquitectura. Digo, en algún sentido también es una disciplina bastante plástica, en el sentido de moldeable, y que se constituye bastante en relación a cuestiones que no le son, que no son parte de su expertise, digamos. Y, digamos, no, una cosa que pensaba, en realidad tengo algunas cosas que te quería preguntar, pero me parecía interesante que el peso, digamos, con el momento en el que propone pesar los edificios, quizás paradójicamente, o eso sería lo que te preguntaría, ¿qué pensás? Es una cualidad extensiva de los materiales.
Sí.
Digo, viste que hay como un cambio de tono y como de, no sensación, pero de sensibilidad respecto de estar pensando la ambientación, pero en un sentido científicamente riguroso, que sería la termodinámica, digamos, la temperatura del aire, la velocidad, las presiones, si está cerrado, no sé. Cosas que ahora de golpe están de vuelta en primer plano, como no sé, la ventilación cruzada, ¿no? La ventilación de ambiente, etc. De ahí pasar al peso, que es justamente una cualidad extensiva, no sé, digamos, tiene como, se vuelve, se torna más mecánico. Mientras que las cualidades intensivas, al menos como vos mencionabas, tienden a introducir un pensamiento global o general de los edificios, ¿no? Y no tanto de partes.
Sí, me parece que lo que sucede es que al medir, en ese caso, esa magnitud del peso, ¿no? Lo hace como medio para abrir la cuestión del mapa, ¿no? De la idea de que el edificio tiene una temporalidad, porque su manera de constituirse tiene un proceso atrás. Entonces, estoy de acuerdo con lo que dices, es como es una aproximación que no tiene tanto que ver con la oposición, de la cual en principio se está colocando del lado de lo holístico integral como sistema de relaciones que transforman y generan novedad, pero está llevándolo para otro lado. Entonces está introduciéndose a partir de lo extensivo hacia una de las cosas que postula, que es esta idea de lo terrestre, ¿no? Como de que los edificios están en la interfase, son como artefactos en el planeta, digamos, y usa esa terminología, ¿no? De lo planetario y de lo terrestre, como para hacerlos como ese belonging a cómo se constituyen, y abre esa didáctica. Yo creo que claramente hay algo ahí, que no sé a veces si es más que al mirar estos edificios que para él son el paradigma de lo extensivo, a través de verlo de esa manera, después los abre, pero efectivamente hay algo como, digamos, no lineal en la argumentación que lleva a tener esa planilla de pesos por cada tipo de material, ¿no? Pero creo que lo vincularía de esa manera para volver a darle sentido, ¿sabes?
Claro. Sí, no, y después, siguiendo un poco, no, pensaba que había algo que decías que era, no sé qué palabras usabas, pero de que lo recuerdo así, como que generaba múltiples relaciones, su discurso, su aproximación a los edificios, con múltiples formas de práctica de la arquitectura, o más profesionales, o más académicas, o más técnicas, más experimentales, menos experimentales. Pensaba que, digamos, para tratar de entender parte de lo que estaba operando ahí, creo que hay algo de como volver a traer algo primitivo de la arquitectura, como la ambientación, la climatización, etcétera, pero desde una mirada muy contemporánea, digamos, y en eso me parece que se vale sí, me parece que se vale de herramientas científicas, me parece, ¿no?
Uh-huh. Sí.
Hay eh, sí, no, sí, eso.
Sí, creo que eso también genera como una confianza, hay como una cosa pragmática en algún lugar, ¿no? Como táctil, explícita, una técnica. Sí, es cierto. No sé, o sea, a lo mejor, no sé hacia dónde lo estabas pensando llevar, pero me parece que a lo mejor bueno, no sé, para mí lo interesante era como que la constitución de ese argumento en el no querer ser ni técnico, ni filosófico, ni puramente arquitectónico, ni formal, fue como encontrando sus límites y encerrando su sentido, y que eso es una manera de pensar en sí, y que es nada, como igual que la semana pasada, o bueno, hace dos, nos preguntábamos qué significaba como un tipo de investigación a lo mejor más, digamos, limpia o segura en sus, digamos, ejercicios. Aquí sería como una forma de argumentación que identifica todos sus puntos débiles y les da la vuelta y los vuelve parte del argumento propio. Y eso a lo mejor me preguntaría qué le hace a la técnica, porque al final a mí por ahí no me queda tan claro cuál es el set de técnicas, o a lo mejor es como si fuera que está tan claro que no hace falta hablar de ellas, y creo que ahí es donde a lo mejor el centro del argumento queda como postergado a la voluntad de cubrir todos esos puntos débiles, ¿no? Y me interesaría saber cómo, digamos, ojalá nos estuviera aquí y preguntarle eso, decirle cómo funciona para ti hacer este como cuádruple salto mortal y no explicitar las cosas que a lo mejor son las que más funcionan en el centro de la argumentación. Me parece que es muy interesante como manera de, nada, como de aproximarse a un problema tan complejo también, como la idea de medio ambiente en la época en la que estamos, ¿no?
Sí, bueno, quizás pensaba en eso y quizás podemos pasar a ver la conferencia, pero pensaba justamente eso de que es muy interesante verlo como una respuesta muy arquitectónica, una sensibilidad muy arquitectónica a un problema acuciante, digamos, al menos en la coyuntura actual, que es el de la sostenibilidad, digamos, y el medio ambiente.
Uh-huh. Bueno, veámoslo.
Muy bien.
Gracias, Manuel.
Vamos a ti. Nos vemos
Nos vemos. Hasta la próxima.
en el próximo archivo.
Well, thank you for bringing me down here, Santiago and Ciro, and thank you for spending this evening on this talk. And I guess I think we got a sense of it from what I got of the introduction, that I'm engaged in architectural questions about energy, but not the usual kind of technocratic managerial understanding of energy efficiency or sustainability or something like that. I think we have much more profound things to learn about architecture from questions of energy. So I'll try and describe some of those to you tonight. And one way to help to start to frame that is that basically with my students, I'm always, and my colleagues, making a case for much more open models of design. And when I say open, I mean that the philosophical, scientific, formal, historical, social, and political and ecological systems that presuppose any building could benefit from a more open model of what architecture is, how we produce it, and its potentials in this century. I begin with this because the models that often govern how we reason and imagine architecture today train us to assume that buildings are isolated objects and isolated acts of design. In doing so, architecture has long externalized consequential topics, including the relationship between energy, matter, and form. So rather than an isolated object, I know that architecture's sport to form reflects intense pulses of matter and energy across a range of temporal and spatial scales. And to understand design in the context of these open systems require us, again, to reconsider our models of what we think architecture is and what it can be. But since this is a somewhat general framework, I'll further frame my work this evening more specifically with reference to the topic of appearance in architecture. Literally, how do buildings come to appear? I've been long compelled by the fact that late in his career, the American architectural historian James Ackerman shifted his attention to the role of magnificence, or the state of splendid appearance, as he saw it manifest in Palladio's work. Palladio and Ackerman reflected on magnificence in terms of Aristotle's Nicomachean ethics, in other words, a speculation on how people might best live and thus design. While Ackerman was mainly concerned with the virtue and virtuosity of Palladio's public works, for me, questions about the appearance and possible magnificence of architecture today necessarily invokes other domains of design. The splendid appearance of a building now implicates not only the outward character of an object, like Palladio's grand facades, but also invokes other architectural questions concerning how buildings actually come to appear in the world in the most literal, energetic, and material of terms, such as their planetary modes of production and assembly, their energetic and material flow fields, and how architecture appears to the visual and non-visual sensory apparatus of our bodies. It also concerns, perhaps more critically, the otherwise unquestioned methods and frames of reference we use as designers to engender and describe the appearance of architectural artifacts and phenomena. In my view, only a deliberate convergence of these inextricable causes of appearance might engender a magnificent act of architecture today. This convergence thus situates the topic of appearance, especially a splendid appearance, in a more contingent and open context, and in ways that I believe multiplies architectural ambition and agency. As such, in my account of appearance hinges on a deceptively simple question, which is what actually causes architecture to appear the way it does today. And since I remain unconvinced and even bored by both sides of a dominant fake debate and chronic false choice in architecture that reductively demands that we choose between equally deterministic claims of autonomy on one hand and autarky on the other hand, I'm necessarily more interested in the seemingly simple question, how else might architecture come to appear today? And tonight, I'll frame my work about appearance and with two essential topics that are particularly relevant in open systems thinking about architecture. So the first deals with the extensive and intensive properties of architecture, which is some basic language that comes and concepts that comes from physics. Extensive properties such as mass, volume, weight, and length are proportional to the amount of material in a system. These are the traditional variables of design, and the formal virtuosity of design today remains almost exclusively focused on the modulation of extensive and static properties of architecture. Intensive properties such as temperature, pressure, density, conductivity, and color are not proportional to the amount of material in the system, and thus introduce degrees of freedom for transformation, as well as the possibilities of novel states within the same architecture. Intensive propensities enliven buildings by activating duration and all the energetic gradients, material assemblages, and much more importantly, a lot more of the politics of building. Come on, guys. The extensive and intensive attributes of architecture are neither binary properties, nor do they engender binary readings of architecture. And I'm committed to the reciprocities that exist between the extensive and intensive possibilities of architecture. To put the intensive and extensive kind of in proto-architectural terms, just think about a cube that has an explicit extensive volume. Its length, volume, and weight, for instance, might be constant. As such, it's easily divisible and can be recombined with no change in the system. And even in extensive terms, even if you start to reconfigure those two halves in some other configuration, from an extensive point of view, they're all constant. If we look at the kind of intensive equivalence of that same cube, intensive division does not behave the same way. Cutting a 60-degree volume of air into two does not produce two half volumes of 30-degree air. Maybe the more interesting thing happens if you mix a 30-degree and a 60-degree volume. Pretty quickly you'll get a new state, which is called 45 degrees. And this is, at its core, a kind of basic missed opportunity in architecture because extensive variation produces no state change, whereas intensive variations is capable of producing new states. And this is kind of a basic, both scientific and philosophical concept about theory about form and transformation. So to put this kind of thinking more specifically in the context of a project, this is just a student project. I'm going to show mostly kind of pedagogy and some research tonight. I'll talk about one of my buildings on Friday morning with some of you. So this is a first semester project at the GSD. So this is a graduate student with no architecture background. And all she was basically studying in this 3-week project was just the relationship between a couple variables, extensive and intensive variables of concrete. So more dense concrete might have more compressive strength, so it can span further, but it's also more conductive. has different bearing strategies, whereas less dense concrete, like aerated concrete, has less strength, so can't span as far, has less conductivity, etc. And by simply having her just look at various patterns, almost kind of abstractly, in ways that I think maybe you guys do some similar work here. It doesn't really matter what these patterns are, but they were understood in her case to be patterns of density of concrete. And then having her look at what are the kind of structural implications of that, of kind of more dense bearing walls versus longer span structures within that field. And that through that thinking and through these kind of parameters, a very specific type of plan emerges out of these pattern studies. So what I'm asking her to do is start to learn how to read these types of patterns, both thermodynamically and architecturally, spatially, and as well as structurally, right, all at once. And with those various material properties, also produces a kind of a consistently varying structure and section, which, so for this is a kind of quick, 3-week project, as I mentioned, but I think a quite accomplished, very integrated understanding of a whole set of extensive and intensive properties as the basis of this architectural formation. So this is an example of how I try to get students to think non-reductively about thermodynamics, have them begin to imagine the kind of architectural potential of thermodynamics, while also reading kind of thermodynamic fields as in architectural terms and for their kind of formal possibilities. Another quick example, this is a similar sort of exercise that's based on a hinge dissection. So this is a category of geometry in which, for instance, you can fold that long bar at the top into the square next to it by just through a few simple operations. And if you do a 3-dimensional version of that, you go from the cube to the bar and back and forth. That was basically just a kind of a framework that's not necessarily geometry or mass. It's not an extensive framework. It's more of an intensive framework for just understanding how things transform in this first semester pedagogy. But what students would do is attach different, basically 3-dimensional fields of densities. Again, it could be air pressure or temperature, it doesn't really matter, but they just have these kinds of 3-dimensional, 4-dimensional fields. And by moving this thing around, moving a little slider and grasshopper, produce a whole range of possible configurations of this architecture. And what's really important here is that they have to read this architecturally and start to see principles of organization and form emerge out of this. This type of pedagogy, I think, is important because you can't draw thermodynamics. This is one of my favorite things about the topic of energy, is that, let's just say, architects must draw, but you can't draw thermodynamics, right? But architecture must also be thermodynamic in my mind. So I like that conundrum. So this student would take these types of organizations, and in this case, this was a kind of based on air pressure, so it was a kind of project about inflatable architecture. So basically just different openings, inlets and outlets of airflow produce this particular building and its plans and sections. But on this topic of not being able to draw thermodynamics and understanding that color is an intensive property, the student was even thinking through ways of imaging and rendering this building that I think speak to some understanding of intensive mixing as the basis of the drawings. And then this is a more developed student, a thesis student recently, who I think was working through similar topics. This is just some, he basically would build all these little concrete kind of like ovens, heat them up, image them, draw them in certain ways, and that led to a project, a very iterative project where something would be heated up, and then that would affect the kind of next form that would be added to it over time. and developed into a quite, I'd say, quite ugly project. But you can only see the architecture through a thermal imaging camera. All of its interesting formal attributes are visual, or can only be visualized in a non-visual field. So there's a whole set of, like, for instance, there's spaces in this building that maybe from an extensive physical point of view are symmetrical, but from a thermal point of view are asymmetrical, and that relates to the sequence of the space and that sort of thing. So it's a quite dead object unto itself in many ways, but once you see it through a thermal imaging camera, then everything takes off. And so he's interested in, again, this kind of reciprocities between the extensive and intensive readings of architecture. Now, another important topic that comes out of science, but I think is deeply important for understanding architecture today more generally, is the topic of coordination, or what's otherwise known as the frames of reference that we use to think about space. Now, Cartesian description, which is the traditional, if not parochial, system of coordination, can only recognize fixed objects within fixed frames of reference. Architects remain unwittingly and inexplicably preoccupied with the fetters of Cartesian coordination in which no change can occur. This continues to impose basic epistemological and methodological limitations on design, as well as our politics. Cartesian descriptions like the photograph of a kayaker frozen in a river, taken from a fixed point on a riverbank. Locked within the limits of Cartesian coordinates, architects can rarely imagine architecture coordinated otherwise. Other frames of reference, such as Eulerian coordination, acknowledge the inevitable dynamics of time and flow, yet this model of coordination only describes how energy and matter move in reference to a fixed boundary. This accounts for flow, but does not reveal much about formation. This is like watching the kinematics of a kayaker, but still as a fixed observer on the shore. Although it acknowledges flow, it is not sufficient to coordinate the manifold movements of architecture, and thereby acknowledge what Heraclitus long ago observed, that all things move and nothing remains still. To not fully accept this precept takes all the fun and a lot of the potential function out of both flow and formation. So a third model, Lagrangian coordination, is very important in my work because architecture inherently involves a lot of movement. In the Lagrangian model, you are the kayaker and submit to the ecstasy of flow. All qualities and quantities of the surrounding domain are gauged relative to the moving subject. Any event, sensation, or formation that emerges in a flow field is coordinated relative to these compound movements. In Lagrangian coordination, flow field behavior is described by following a set of material points through time and space. As such, it describes the emergent figures, forms, and transformations that come to appear in the process. This type of morphological description has very important but totally unconsidered spatial and temporal implications for our understanding of form. And I think it's really important to understand that all three of these models of coordination are relative to my understanding of architecture, and that none are taken for granted. So there are, of course, certain times in which I think we should be drawing or modeling in a Cartesian space, and there's other moments where I think we should be drawing and modeling in a Lagrangian space. But we're not doing that right now, and I think that's one of the kind of great missed opportunities of architecture. But regarding this Lagrangian model, it's one reason I did this book called Empire, State, and Building was to start to think through one type of Lagrangian modeling in particular. So what this book does is basically I just accounted for every single material that ever occurred on the site of the Empire State Building in New York City over the last 200 years. So through its whole urban morphology, just mapping all that stuff out, its whole material geographies, tracing exactly where all the bricks came from, or pieces of steel, that sort of thing. So following the materials is a really important Deleuzian concept that is Lagrangian in its basis. The other reason I did this book was based on the outcome of a previous book, The Hierarchy of Energy, which Santiago mentioned, which is applying ecosystem science to energy analysis and architecture. And this is maybe the slightly I don't know, maybe more boring technical work that I do, but I think still has deep philosophical and conceptual implications. So this book just did an analysis of like the most totalizing energy analysis of a building. This happens to be at the University of Florida. It's a very boring school of construction management. We just have lots of data on this. And so what we do is we just map all of the energy inputs, throughputs, and outputs using this ecosystem method, and develop charts like this, which again are quite maybe boring, but once you start to organize it into this, what's known as the hierarchy of energy, then I think some really important things emerge for us as architects. For instance, if you do this type of ecosystem assessment of a building, then 80% of the energy associated with the building deals with construction and maintenance, and only 20% is operational things like heating, lighting, cooling, etc. What architects have traditionally been obsessed with in architecture when they think of the topic of energy. So this incredible role of construction and maintenance, the kind of spatial and temporal dimensions of building, are so important and so unconsidered and externalized that that's another motivation for this book on the empire, state, and building. So again, as I mentioned earlier, that the buildings really are this kind of pulse of matter and energy over space and time, that it's really, a building's just a kind of transformation, usually in between all of these other states, and we need to start to come to understand that. So that was the basis of looking at this building in particular. The other way to say that is just, where the hell does all this stuff come from? I'm kind of shocked as architects that we don't know or don't care about this kind of question. And I selected the Empire State Building for this study for a number of reasons. It's had an incredible archive, but from a kind of architectural, political, thermodynamic point of view, its name is really quite incredible. There's the word empire in that title, which is an ambitious but apt term for a project focused on the geographic and political forces that are behind the metabolism of a building. So basically, I make the claim that every building is an empire, but it's an empire without rule because we don't pay attention to it. We don't design it as architects. And empire is the title of the first chapter of the book. State is the title of the second chapter of the book. State is a good word in English because it's describing obviously the kind of political apparatus of a geographic unit, but it's also describes the kind of macro dynamics of the kind of macro thermodynamics of a system. So, but state is both a kind of, in English, is both a kind of political term and thermodynamic term. So that's in that section is where I do a lot of the analysis and kind of political analysis of what's involved with building on this site in Manhattan. And so thinking about empire and thinking about states as major topics allows me to rethink what building actually is. That's, again, not a static object or a noun, but it's a kind of much larger master process of urbanization. It's a very active political entity. So thinking about building in other ways, I think, is a way of extending architecture's agency today. And of course, there's empire building and state building as we draw and especially specify our buildings. There's also a kind of historical and political component to this, that a lot of this project was inspired by Braudel and the Unal School of French history. And basically, after his 3 volumes of History of Capitalism, he said it'd be best if we could just simply weigh urban systems. And that's all I'm really doing with this project, is calculating the weights of all the materials. And it actually does reveal a lot about the kind of metabolism and politics of what we do. It also emerges out of a very small section in Delirious, New York, that Rem Koolhaas had, where he describes this transformation of this site from from a farm to row houses and a hotel to the Empire State Building. And he described it in a very specific way. He talked about it in terms of it's a type of architectural cannibalism, and that it somehow accumulates all of the kind of what he described as strengths and spirits, kind of material properties and non-material properties of these buildings over time. This relates quite well to the kind of ecosystem analysis, actually. The vocabulary is quite identical. But again, all I did was simply map where all of this stuff came from, all the material for all of these buildings. It starts in 1799 when a farmer bought some 20, I think it's about 25 acres in the end, 22 acres in Midtown Manhattan for $2,500. And this is the future site of the Empire State Building, and that's his plot of farm. And he just grew vegetables for the wealthy families on the southern tip of Manhattan. But it was a very, of course, a very simple site, very simple ecology. They can even understand how his farm evolved over time, how his family grew, how he grew his house. But the kind of empire and state of that farmhouse is quite local, as you can imagine. But even in 1800, it's a planetary proposition with materials coming in from all over North America and across the Atlantic. So I'm always looking at these as kind of states of this building in a certain sense. By the mid-19th century, like most of New York, this block is filled with 4 or 5 story masonry row houses. And there was a couple large kind of mansions on Fifth Avenue that were a part of the Astor family. So there was these 2 larger row houses. And they, of course, had a slightly different material geography, but as you can start to see, 50 years after the farmhouse, you start to see an increasingly large global geography for the empire and state of these row house buildings. And then one of the Astor, members died. The guy who built the house on this corner, he died, gave it to his nephew. His nephew didn't like New York anymore, so he tore down the house and built a 13-story hotel, basically just to make money. And but also in part to spite his aunt, who lived to the north of him in this house. So he put her in shadow all of the time. She didn't like that very much, so she built another house by another architect and moved further north in Manhattan, and built a 16-story hotel that matched the first 13-story hotel, and this became the original Waldorf Astoria Hotel in New York City, which remains a very popular hotel. But this building, which is a great pile of stone and masonry and steel, could have lasted for a few hundred years, but it lasted 36 years, which is quite common for this. Basically, the first 3 constructions all lasted about 35 years each. And I go into quite great detail because I have, even research on how many loaves of bread and how many chickens were consumed in this building every day, how many cups of coffee, how many dishes washed, etc. And so there's the kind of, daily metabolism of these buildings as well as their larger metabolism of building. This building happened to use as much, it consumed its own volume in heating oil at that time, because there was no kind of centralized power system in New York City. Every building was basically its own power plant. So to run this hotel, which was basically the living room of New York City and all of its meals and all the guests and everything like that, consumed quite a bit of fuel. But here you can start to see the kind of extravagance of the material. It starts to creep out further and further. Buildings becoming more of a planetary proposition. This is one of my favorite photos of this building. This is when it was sold to some new owners, and kind of to demonstrate the stupidity of tearing this building down, they had this photo taken of them kind of to launch the demolition of this building, which is a stone building, and they go up there with a wood saw to start taking it apart, I guess. It's quite funny. But this building was, they simply just started driving dump trucks into the lobby and tearing the building apart. And so this building's quickly demolished in the space of a couple months, and all this material is loaded into trucks and then onto barges, and then dropped, sorry. Sorry. And it's all loaded, and then it's all dumped off the coast of New Jersey here, off of Sandy Hook, New Jersey. So that whole mountain of material still is out at the bottom of the ocean out here at this particular dump site. And then, of course, this was to make way for the Empire State Building, which is one of the kind of fastest buildings ever built. The steel that arrived from Pittsburgh was still warm when it was on these trucks when it got to New York City and was installed. So this building grew quite rapidly. All of its sort of details are about the kind of velocity of its construction. It's quite astonishing. And it was because it was kind of the product of scientific management. There's all this kind of documentation about where all the material comes from. So this is where the kind of Lagrangian thing comes into play, because they start to design the building in charts like this, which are about the kind of sequencing of steel construction versus masonry construction and envelope, etc., and about how those systems relate and how they're coordinated. And of course, this results in the most planetary of all of the empires involved with this particular site. But again, just keep this in mind that this is still 1929. Any contemporary building is very much a planetary proposition. And so we might be obsessed with the kind of intensities of these objects in a city, but increasingly my understanding of the energetic question for architecture is much more at this scale. And I think so it's more of a question of how the kind of reciprocities between this kind of territorial thinking and its specificity with the specificity of the building itself. So this is just some of the analysis. This is just the weight of each of these buildings, so the farmhouse, the row houses. And what's super interesting is that the hotel and the Empire State Building that replaced it are basically the exact same weight. And so all we did was basically figure out how to get more people into the same volume or same weight of material. And that actually helps the kind of ecological analysis of this quite a bit. Basically just getting more people in there, getting more work out of a particular parcel of land is what is, in my mind, useful about a kind of urban situation. So, but it turns out that the farmhouse and the skyscraper have the same sort of ecological efficacy from that point of view, whereas some of these other constructions have a completely different order of magnitude in terms of their efficacy. So, but a big part of this, of course, is the concept of obsolescence and maintenance and duration. So how long we let buildings persist has a big effect on their efficacy. If we allow things to exist for a much longer time, then that completely changes their whole empire and state over time. I also looked at if we had to replace the Empire State Building today with some kind of bad lead building that you would get in New York City today, with kind of double glazed facades and all those kinds of neoliberal tricks about what's involved with what they call sustainability, then that kind of building would require about 3 times as much energy as the Empire State Building did itself. So obviously pretty dubious from a sustainability proposition if that is in fact what it's about. And also, in a get back to the kind of thinking about the Lagrangian understanding of buildings, I have a whole kind of analysis and section talking about the velocity of each of these buildings and each of the material systems in each of the buildings. But of course, because buildings start somewhere, they end up, like in New York City for a while, and then they're redistributed back in the environment. There is a sense of velocity and momentum that's involved with architecture, even at that scale. Within ecosystem science, the kind of velocity of material and energy in a system is extremely important for how we might start to, evaluate the kind of efficacy of these types of systems. So again, from a Lagrangian point of view, just understanding that, let's say, questions of assembly are occurring at multiple scales, that the appearance of a building has as much to do with maybe this sort of view of building as it does with any, plan or section of a building. But again, for me, it's the kind of reciprocities that exist between those two. So almost all of my books have a kind of trailer in the front. There's like, you can just read the first 10 pages and understand the whole book, because I know we don't read books anymore. And so this is part of the trailer. Again, that building's an empire without rule, that architects are, we appear to be our most vague in our acts of specification, right? So when we specify concrete or drywall, we actually know nothing about that, pretty much, I would say. And again, I think this puts us in a pretty politically precarious position. So the book is ultimately about asking a question about what's the constitution of architecture, and I mean that like kind of in the physical sense, like what literally constitutes all of these buildings, but also in the political sense, like what are the political implications? What is the constitution that we have with urbanization, with people, with states? So what is or what should be the constitution of architecture today, and therefore what should be the state of building? Okay, and so just to wrap this up a little bit, whether we're thinking about the extensive and intensive properties of architecture or various types of coordination in architecture, for me it's ultimately a question of, again, in a scientific sense, of how do you couple these very different systems. I'm going to talk about how I couple these kinds of systems and thinking in one of my buildings on Friday morning. This little wood building out in the middle of nowhere in Colorado. But, as I mentioned, how do we start to couple and coordinate maybe the interiors of buildings with the larger extensive and intensive organizations of buildings and all their temporal, spatial, and energetic assemblages? And then how do we couple those concerns yet again with even larger compositions of form, that is matter, energy, space, and time, that I think are inextricable from how we might best live today. So in my mind, this type of account of thinking about appearance in this sense is part of a kind of more cosmopolitan understanding of form and formation. And it does have some technical content, but I think it has, for me, mostly implications for how we think about form and formation. So I'll leave it at that. I think that's enough for some conversation. And I don't know, it's probably fairly late for some of you who've been on reviews all afternoon, but I'd be happy to take any questions. And if there's a few questions, maybe I'll take several of them at once, and we'll see what people are interested in. But otherwise, thank you for listening. So are there... Yeah. Other questions? You have one. You're almost... Yeah.
I was going to ask you, because you were studying the Empire State Building that, as you know, has been renewed lately. If you have done any studies about this new, because they didn't, thinking about this movement thing and distances and so on, the
Yeah.
in glassing. So if you have done something further on about.
Okay. Yep. And then up here.
No, I was just looking at the first diagrams that you were showing about the dynamics in some diagrams and the work of some of your students. And at least my impression was that you were using some diagrams to sort of create form. I was sort of wondering if you were also looking at it in relation to performance. How you thought about how these thermodynamics actually keep the form of the spaces of buildings and not just the appearance.
Yeah. Okay. Yep. Are there other? All right, we can start with those. Maybe more questions will come. So on the Empire State Building, and it's so there was a basically a new young owner took over the Empire State Building and did a quite complete renovation of that building quite recently, within the last decade or so, and it was mostly a kind of energy retrofit. Like they were trying to increase the performance of the building in different ways. But you mentioned, I think the most interesting part of that renovation was they decided to keep all the original window frames, and so they took an empty floor of the Empire State Building and basically turned it into a glass factory. And so they would take out a window at night and replace all the glass and put a new one back in the same night. And so they had a whole way of moving through the whole building. And they put like insulated glass in the old frames, and repainted the whole frames and everything like that. And that was basically one of the more interesting, I think, kind of material and energetic parts of that renovation. The rest of it's I'd say quite mundane, just better, boilers and furnaces and air duct systems and that sort of thing. So I think that the window example is the only time that I think they're actually thinking at multiple scales at once, and thinking about the kind of construction energy as much as the operational energy, which is where they're actually way ahead. If they replace those with more expensive fancy windows from Germany or something like that, then they would have undone most of the ecological purpose of renovating that building anyway. So, and on terms of form and performance, that project in particular, if we're thinking about maybe something like this kind of project, it's a very short first semester exercise, so they're not doing any type of let's say analysis where they would make some sort of claim about the performance. But I guess what I would say in response is I'm more interested in the fact that they can start to read this thermodynamically as an architect and be able to engage, let's say, performance criteria and much more from an architectural point of view rather than a kind of bad engineering point of view where it's just about efficiency or something like that. So I want them to have a kind of formal, spatial, whatever, architectural agenda for thinking about, let's say, heat transfer in the slab or something before they start learning how, whether the basic calculations or simulation software that they might use. Some of my advanced students might get into some of that stuff, but again, in my research, that 80-20 split between construction energy versus operational energy is so important that to really talk about energy, you're really talking about materials these days. So I have them, any type of technical analysis they do is at this much larger scale of material and construction and maintenance and that sort of thing. So, but again, I think any of those lessons, any of those important, let's say, habits of mind that we should have from a technical and ecological point of view, I think come back to this kind of, I'm trying to prepare an architectural mind to think about all of those things and be able to integrate them and coordinate them with other architectural agendas about the building itself. Does that make sense?
Maybe regarding that, I don't know if I can construct really well the question, but I will try. Regarding the agenda, because it seems that how you present the idea of thermodynamics, even this project, it's like the agenda is still kind of, the disciplinary agenda is still kind of silent. You work directly from the thermodynamic problem in the sense of what is the end of that? why using thermodynamics that is not only for the goodwill of making the world a better place or something like that. And I mean, which is there a general agenda, or is flexible enough as a problem to subsume any multiple agendas that there are? I don't know if it's...
Yeah. Okay, so I think basically the question is about that I still am engaged in various types of scientific analysis or concepts or something like that, and is that actually flexible enough to include architecture or not? Is that the kind of...
Of beyond that, if there is an agenda, a disciplinary agenda. Well,
Yeah,
is
okay.
case now, right? In the moment that there was an agenda, a clear agenda regarding the environment.
Okay. So is there a disciplinary agenda by looking through thermodynamics? Yeah. And I would say absolutely. I would say that let's say just, I'm working on a kind of very large thermodynamic atlas of architecture to, I think, help resubstantiate the role that thermodynamics has always played in buildings, right? Like, whether it's Loos, Alberti, Palladio, any of them, like their kind of origin story of architecture is always about a warm, livable space, or about the fire, or something like that. So I'd say that most of the treatises in architecture actually start with a thermodynamic argument, right? Like, for Vitruvius, it's people coming together around a fire, learning how to speak, and then they start to build constructions around that fire. And I think there's a kind of deep physiological purpose for that and everything. But I think there's a very kind of specific disciplinary claim to make on that. But for various reasons in modernity, we've been quite divorced from, let's say, the kind of thermodynamic parameters of architecture as kind of disciplinary concerns. They've always just been treated as technocratic and proprietary concerns of other fields, and the best that we can do is kind of so-called integrate them, and create spaces for ducts, and all this stuff that we hate in architecture. And so I think there is an important disciplinary claim. It was great when Iñaki was at the GSD, because I think that was a big part of the discussion about what the discipline was. So it's there. It's hard to walk a line, because it's tempting for some students and some architects to kind of just become kind of bad positivists and bad technocrats when they start to deal with questions of energy, just because there's numbers or something involved. And so that's why I'm more interested in these kinds of exercises that maintain some kind of what Karl Popper called plastic control, that they, you can engage science, but you can also be somewhat plastic in that engagement. So I don't know. I don't want any turn for architecture to become determined by thermodynamics, but I know that there's not really any architecture without thermodynamics. So I think I do want to claim it as a disciplinary concern, but it's certainly not the conventional disciplinary concern for sure.
Following on his question, I'm trying to phrase it that I would like to know more about your structural politics, but in a more specific level, like within the context of thermodynamics influence in architecture in the past few years, and along the genealogy of other people having thought of that in the realm of architecture or other realms, like your go to Prodel or Ana de Landa, or those kinds of genealogies. How do you more specifically locate your work, and what do you think? Well, perhaps your academic practice or your books, what do they do in that very specific cultural context?
Yeah. So in terms of the genealogies, I mean, again, I think there are relatively few, let's say, big books on this kind of topic in architecture, and people always bring up Banham or something like that, and I think it's a completely different agenda than what Banham was ever thinking about. I don't think he was thinking about thermodynamics or anything like that. he was thinking it through art historically. So there's not too many big books that I would point to in terms of a genealogy, but there are other, adjacent disciplines, and Delanda has been big. I mean, teaching with Sanford and, et cetera, that's been important over the years. And so it's, there are kind of, other disciplines that get involved, but I think for me it's, I don't know, the books are about kind of establishing what this genealogy would be, this kind of alternative, and the book in particular with Sanford is very much about that. It's about establishing kind of retroactively what that reading list ought to be, or what the kind of canonical readings are for architecture and energy. I think that's, in one sense, that is part of the project, is just to kind of claim what that is, because I think Galeano did part of that. Luis Fernandez Galeano did part of that with his book on Fire and Memory. But there's been very few others that I think make a kind of substantial claim about what the kind of disciplinary role energy actually has in architecture. So each of them are trying to do that in different ways. I mean, Empire State Building does that in a very particular way. I think maybe the more important one, the more scholarly one, is the Insulating Modernism book, which is, on the face of it, it's the most boring thing you can do. It's a history of insulation in buildings, which is, like nauseating to even think about, but it actually, of course, reveals all kinds of important assumptions and concepts. What I like about it is that the Latin root of insulation, of course, is insula, which is to isolate or to set in a detached condition. So it was that whole discourse in modern architecture about insulation was about isolating buildings from their environment, isolating them from their metabolism, etc. And so, it's the kind of scientific, and of course it gets political with insulation pretty quickly, about what that kind of isolating habit of mind produced in modern architecture, and therefore what a more open system or non-isolated kind of genealogy would be, or what a kind of non-isolated building would be. So the kind of genealogy question is a little tricky, just because I think that is the project to some degree, because once I started scratching at the surface, there's not enough there, so I feel like I had to kind of build that up in my own sense.
And the other side of the question was more kind of bordering gossip, actually, which is, how do you see your role in the internal politics at Harvard, particularly at the time of Iñaki, but even now?
Yeah.
What do you think what's your edge in that? What are your affiliations, subtle differences, fights?
Yeah.
Things you want to differentiate or work from, even if they look similar?
Right. Well, it's interesting. I think that let's say the internal politics of Harvard have evolved quite, in the 7 years that I've been there, quite significantly. I think at the beginning, like this pedagogy in particular is in Scott Cohen's first semester studio, and I think he liked seeing this kind of, let's say, the formal possibilities of thermodynamics coming into the conversation, and understanding that it could be something more than just technocratic numbers or something like that. So it was welcome at that point. Recently he's gotten very conservative, and so this is no longer welcome. So that's been a big change. But I would say in general, I mean, the GSD's become just increasingly neoliberal for various reasons, and I think that just puts me in increasingly, even day by day, much more a kind of countercultural figure at the GSD. And so students are looking for some kind of alternative. They end up in my studios and my courses if they want to understand something else about form, or something else about history, or something else about energy and materials, and they usually end up in my thing. So it's not necessarily by choice, but I've just become, I think, a kind of countercultural, somewhat peripheral figure. But that provides a certain kind of agency that being in the center of the panopticon doesn't permit. Yeah.
there seem to be implications in the research, at least that you're presenting, and then between the way that you talk about the politics of PhD and pedagogy, and I think that you were also teaching Insert.
Yeah, I've taught Insert.
It seems like there's an opportunity, and I guess my question is, do you see this as a ripe opportunity or something that you would distance yourself from? Do you engage in the discourse of ethics?
Yeah, ethics, and I have a thesis student right now who's a really smart guy, and he's totally committed to doing a thesis about morality. And he's using straw bales to do this. It's like so loaded and like just like it could be a total disaster, but it's a super interesting conversation. And I agreed to do it because of one of my favorite readings, which is on the reading list for Friday. Is Nietzsche has this aphorism on energy, about the world being a monster of energy, and basically just says that that energy is beyond good and evil, right? That energy has no morality, and I love that because we typically think that energy is maybe one of the more kind of moralizing terms in architecture or something like that, but that's not. I agree with Nietzsche that it's actually quite neutral. It's how we treat it that becomes political or ethical or amoral or something like that. And I think that that's a really important conversation to have because I think its typical treatment is completely unethical, completely cynical in terms of like energy efficiency and lead and those sorts of things. And so I like having the kind of conversations about morality, but it's not the normal one that I think we would assume that we would have with, say, any kind of environmental studies in architecture. So yeah, but not in the ways that initially might come to mind. And I think that's where it gets super rich and interesting. It's basically all the kind of ethical, moral assumptions invert if you get serious about energy. So I like that game, and that's why the building scientists and engineers don't like my discourse at all, because it complicates their very simplified morality and asks some tough questions about that. But yeah.
Sorry, follow up. Is that then, if you really, really boil it down and simplify it, is that going back to then the kind of temporal aspect of this? That it's really about looking at something in a much wider frame, its flows, and kind of points of view, reference points, that you get this inversion of what the technocrats might say versus what your research shows?
Yeah. I mean, on a kind of simplified level, yeah. I mean, it's and that's where the conversation with Sanford actually started. As it's just told him, look, I mean, what you were talking about with time, architectures of time, architects didn't really understand it. Like nobody went deep enough with it, and that's why we started teaching the class to kind of go deeper into all of the kind of scientific references he was using and everything like that, and just energy, thermodynamics is a better way to get at some of those deep concepts. So yeah, time is, and I would just simply say duration is probably the big difference between, or it's one way to describe some big difference between, say, my research and some more mainstream kind of energy or architectural research. Okay, I don't think any students have asked anything. Okay, go.
At the beginning, you talked about the object or looking specifically at the building in a static way, and then you talked about pulses and about time and space. Are you also projecting those ideas of the scale of the territory or the city?
Yeah. Well, I mean, I guess that's definitely part of the big point of the Empire State and Building book, was to look at it as a kind of urban system, and at least the way that I feel like North American architects engage urban systems is actually through the specifications that they make. So understanding that a building's deeply territorial, You know, so even my tiny little wood buildings, you know, are totally territorial propositions, and I think are actually quite large in that sense, even though they're small buildings unto themselves. So in that sense, yes, but in terms of like urban plans and that sort of thing, not necessarily. I mean, I've gotten through this kind of work. I've done some kind of urban scale work, but with small towns, you know, like 2,000 people, that sort of thing, to start to get a sense of what, you know, how that would play out as a, you know, as a kind of urbanist in the, you know, more traditional sense. But I haven't. It's like just to do like a 600 square foot building, at like, and keep track of all these sorts of things is really complicated. So by the time it gets to the scale of Manhattan, it's like it's pretty crazy. And even, you know, like just looking at the building in this way is extremely reductive in that sense of kind of Manhattanism, you know. So.
I was thinking that assuming part of your work is focused in, let's say, moving from outside of positivist technological paradigm. So I would like to ask you if do you think that implies the recognition of the existence of a certain specific condition in, let's say, I don't know if or both vernacular or pre-modern architectures that are capable of being rethought in generic terms beyond the condition of origin.
Mm-hmm. No, that's it's a good observation. My current lecture course is on non-modern buildings, and the simple operative definition in that class is just anything that's not modern, and then we have to define what modern is with them, but includes things that we might call vernacular, which is like it ends up being a pretty pejorative term, because I mean some of those are super interesting buildings, but also like let's say the next 100 years of building, also understanding that to be non-modern in some way. So I think we're looking ahead and back and forth in that sense. So yeah, I think there are, I guess I'd like to have a couple of my students here to see if they agree that there are some generic attributes of the non-modern that we've identified that I think would be part of a non-modern practice in this century. I mean, there are insights to be had from some of these vernacular organizations, but it's never about just sort of repeating them or kind of reenacting them or something like that. It's looking at them for certain habits of mind, certain material, like how they exploited materials in certain ways, because like Vitruvius and his description of the origin of the dwelling house is basically, he's just reporting on about 3,000 years of human evolution, about how our bodies evolved, how social organizations evolved, and how architecture was implicated in all of that, right? And so it's just, there's a lot of thinking and experimenting and self-organization that goes on in some of those contexts, and that's what we try to extract from looking at those types of buildings. But there are some, very contemporary and even buildings that are from the non-modern period that I would describe as non-modern in interesting ways. So I think it's fairly flexible in the sense that we can look. We're just scanning for opportunities that are non-modern rather than being a kind of art historical periodization or something like that. All right, just at least one student has to ask something. Okay, here we go.
He's about to graduate anyway.
Okay. Yeah, it depends on the question. Yeah.
How does, and I was interested in the final maps of each period, time periods of the Empire State Building and how it keeps getting more global. I find that the obvious way of thinking is that this will continue until covering the whole globe, but do you see that there is something that doesn't go along with that logic? Like, do you see that in the future different things can concentrate in different parts of the world and like regroup those lines, or do you think it's a fairly safe assumption to think that this will go on and on and on until it covers the whole?
Okay, no, it's a good question. And maybe that kind of answer the first part of it is that yes, like now buildings are completely planetary in their empire, right? Like, you know, stuff comes from everywhere, and that's the product of, again, a very neoliberal kind of organization of nature, let's say, and on one hand that's okay or that's fine, kind of indifferent. It's not about some kind of localism or something like that, like local food or something might be. My point is that architects should just be aware of this, because I think there's tons of agency in here. So like a graduating student, one of my best students has now graduated and moved to LA to work at, you know, AECOM, which is one of these, like, you know, planetary architecture firms with thousands of people. And she applied specifically, and she's a very good designer, but she applied to be a spec writer because she wants to be designing these organizations for all of these buildings that they're doing, that she understands that she's going to have way more effect politically, socially, labor, et cetera, things that I think a lot of young people are interested in by doing that or whatever. And so it just opens up other types of agency, and I think, again, it asks other questions about what architecture is forming. So she can understand what's going on with the building, of course, in a very literate way, but she wants to, you know, develop some other sort of practice, giving her own politics or whatever. Yeah. Does that make sense?
On the other hand, that's why I was asking you about the window plane, because it's turning to be more local in a way. The lines, instead of going out, they are kind of rounded.
Yeah.
So that's
and again, but it's like one of the faults of the morality of energy discourse is usually they always just want something. It's about minimizing this or maximizing that. And it's just much more complicated when you look at these in open systems. So maybe keeping the windows, kind of repurposing and recycling them on site makes total sense. But bringing in some, technological object or something from somewhere far away from Germany or something might have a big effect on the ecology of a building, and that's a good thing, right? So it's not about just saying it's local or it's planetary or something like that. It's I want my students to understand what all of those dynamics are and design accordingly. And this is going to be back to some of the kind of questions about the science and stuff like that. I'm only interested in this type of ecological analysis because it gives me a sense of the orders of magnitude involved, right? So when I start a project, I want to know which of these energy material systems matter, because a lot of them don't, right? So if there's like 1% of the Empire State Building is some piece of metal or something like that, I don't care where that comes from at all, right? So that might be one of these lines, but it has really no consequence. But the concrete and the steel have a huge consequence, so I want to work on that architecturally. So this type of ecosystem analysis, it looks quite technocratic, and I think it is. I'm not interested in that as an end game unto itself. It just helps me identify the kind of orders of magnitude of what matters in a project, right? And then I can ask more meaningful architectural questions about those systems that have either ecological or political influence. It's basically a form of scale analysis. I don't know if any of you have a math background, but scale analysis, like if you have a really complex equation, the first thing a mathematician does is what's known as scale analysis, to basically identify which of the variables matter, and they'll work on those. And they just might set aside half of the variables because they just have no consequence on the final solution. That's basically what I'm doing with this energy analysis. It's just saying, all right, what matters? Is it operational energy or construction energy? Okay, so it's construction energy, so what matters? Is it the steel or the concrete or the wood or whatever? And then get to work on that. So my little wood buildings, yeah, it makes good sense that it's quite local and doing things with the kind of local economy and stuff like that. We'll talk about that on Friday. But it's never about just a kind of localism or something like that. It's just, of course, more complicated and interesting. Should I poke one more student? There's only one student's graduating so far. Yeah.
You have some over there.
Yeah, there's some students there. Some there. Nothing. Okay.
I have a kind of a weird question, but you know how in thermodynamics, you know the rules, so you know what's going to happen. You can predict what's going to happen before it does. And I was curious about applying this to architecture, if there is a way to understand dynamics, like in thermodynamics, like in the building you know how the dynamics were, how they are, but can you in a way predict how they will be?
Yeah, and what are you thinking about, like how they're going to be? Like, is it going to be like the temperature or something like that? Is what you mean?
Like not only analyze what it is, but maybe project what will be of that building using stuff.
Yeah. Okay. So yeah, let's say again for me, I would describe that what you're asking about are the different states of the same architecture over time, and yeah, let's just say, I mean, if you want to know what the temperature is going to be if you under certain boundary conditions, yeah, that's fairly easy to project, or at least make a suggestion of what that's going to be. And I think that's fine and that's interesting. Like I do some of that, but I'm not too obsessed with it as a kind of question. It's not really too much of an architectural question, I would say. But I think part of what you're pointing to is also, I do like thinking about, I have a whole chapter on specifically generic buildings, which I think maybe we'll get into in the next couple days of conversation, but basically buildings that are generic but in a very specific way that allow them to evolve. And so a lot of my studios, like you might be designing a library this semester, but I'll ask you to design 3 or 4 other states of that same building. So how it might in 50 years for some reason be housing or a museum or something like that. So I think that's part of this thinking as well, is understanding how, like, you know, I think many of the good buildings evolve over time, or the specifically generic building that I like the most, that I think is the most profound, is the Salk Institute for Biological Studies, which is a building that is basically on a 3-year turnover now. Like the interior is built, basically it's the period of a kind of a scientific grant in the US. Every time they get a new grant, they have to have a new lab, basically. So that building's constantly changing. And Kahn, Salk, all the building managers, et cetera, they all talk in great precision about how this building basically guesses the future in an amazing way. And I think it's through very specific architectural decisions. It's not a kind of discourse about flexibility or something like that, kind of throwing up your hands like Mies did, and just like anything can happen. But actually, there's specific dimensions and specific material systems and structures that you would use to achieve that kind of endless adaptability, or kind of Dr. Salk's program to Kahn was that he said he needed a building that was a mesenchyme building, which is a type of cell in biology that can evolve to become lung tissue or heart tissue or brain tissue. It does all these different things. It can evolve, and that was literally the program for the Salk Institute. And I think it's a great way to explain like what buildings, a certain way to understand a generic building in a certain sense. Yeah. Good. All right. 2 students is good enough. Yeah. All right. Thank you guys.